The monopolist cost function is where C, of course, is total cost. Part A, formulate profit as a function of Q. Or, of course, Q is output per period. Profit, by definition, is what? Anybody? Yeah, total revenue minus total cost. Now, in order to get our profit expressed as a function of Q, we have to express both revenue and cost in terms of Q. Cost is already expressed in terms of Q, so that's no problem. But we have to get revenue expressed as a function of Q. Revenue, of course, by definition is P times Q. So to get revenue expressed as a function of Q, now we just substitute in for P. P is given by the inverse domain curve. So our revenue function is 100Q minus 0.5 Q squared. Therefore, our profit function expressed as a function of Q is revenue, which is 100Q minus 0.5 Q squared, minus cost, and here's our cost function here. So let's put our cost function within brackets here. Okay. We can simplify this expression a bit by collecting terms. So we got 100Q minus 20Q, that'll give us 80Q. We got a minus 0.5 Q squared here. Then we have another minus 0.5 Q squared there. So we get a minus Q squared. Okay. So that is our objective function. We assume that the monopolist wants to maximize profit. So this is our objective function. We want to choose the value of Q. That'll give us the maximum profit. The first order condition is this. Pi prime of Q, which is just 80 minus 2Q. Set that equal to 0 and solve for Q. And solving for Q, we get Q sub 0, the critical value of Q, is equal to 40. That is our critical value of Q. To check and make sure this is a maximum, we look at the second derivative. The second derivative of our profit function, in this case, just minus 2. It's negative 2 for all values of Q. So we know that the second derivative at Q equals 40 is negative. This guarantees that profit is a maximum at Q equals 40. So we can conclude from this that pi of 40 is a relative maximum. In fact, if we look at the graph of this, I don't believe I asked, did I ask you to sketch the profit function? No, I didn't ask you to do that, but let's nevertheless take a look at that. Here's our profit function. On the exam, I might ask you to do that, so let's just do that. In this case, our objective function's quadratic, and if you graph it, it'll look like this. Starts at the origin, doesn't it? Q equals 0, profit equals 0. So it starts right here. It's going to be an upside down U-shaped. a symmetrical shape here. And at Q equals 40, that's where your maximum is. Not only is this maximum a local maximum, but in this case it's a global maximum as well, you can see. And if we calculate, this other point over here, where it crosses the horizontal axis would be 80, because we know it's symmetrical. Okay. Let's calculate this maximum profit. Pi of 40, I did ask you to do this. So you just go back to this expression right here, get 80 times 40 minus 40 squared. Be 3,200 minus 1,600, be 1,600, wouldn't it? Okay, so this would be your maximum profit. Okay. I also ask you to find the profit maximizing price. We know the profit maximizing output is 40. So if you go back to the inverse demand curve, here's our inverse demand curve. 100 minus 0.5 Q. So if you plug in the profit maximizing output, we would get our profit maximizing price. It would be 100 minus 0.5 times 40. 100 minus 20 is 80. And we'll call this P star. Or Q star is the profit maximizing output. The profit maximizing price would be 80. If I ask you to do marginal revenue, marginal cost, which is part E, marginal revenue, marginal cost, it would look like this. Stop me if there are any questions. Is this clear to everybody? Okay. Our revenue function, recall, is this part right here. That was our revenue function. 100Q minus 0.5 Q squared. So marginal revenue, or R prime of Q, is just 100 minus Q. So it looks like that. Here's our cost function right here. So let me just repeat that. 20Q plus 0.5 Q squared. So marginal cost, which is C prime of Q, is just 20 plus Q. If we equate marginal revenue, marginal cost, we get add Q to both sides, subtract 20 from both sides, divide by 2, and we get this critical value, Q equals 40. In terms of a graph, it would look like this. In fact, let's draw our diagram. Q on the horizontal axis. Price, marginal revenue, and marginal cost are all measured on the vertical axis. And let's go back to our demand curve, our inverse demand curve. And graph it. Our inverse demand curve looks like this. This is 100 up here. and I'll label that D, and it would cross at 200. Because the slope is 0.5. Our marginal revenue curve is 100 minus Q. So it would be twice as steep. I'll draw it as a dashed line. So a marginal revenue curve would look like this. It would cross this horizontal axis at 100. Marginal cost, right here, 20 plus Q, straight line, vertical intercept of 20, and a slope of +1. So our marginal cost curve looks like this. We know marginal revenue intersects marginal cost at Q equals 40. And you go up until you hit the demand curve, and that gives you your price of 80. Right? Wasn't our profit maximizing price 80? Yeah. Okay. So that's what it looks like in the diagram. Okay. In this case, there's only one intersection of marginal revenue, marginal cost at Q equals 40. And notice for any output less than 40, marginal revenue is above marginal cost. So clearly, and at any output above 40, marginal revenue is less than marginal cost. So the profit maximizing output is going to be right there at Q equals 40. Okay, and that's going to give you your maximum profit.